Hello, my name is Daniel, your GRT Mill Lead for the 2020-2021 season. In this second installment of our Mill Training series, I will be covering the tools used to hold your part, the tools used for milling operations, and how to clean up after using the mill. You will have to pass an online test covering this material before receiving hands-on mill training. Before we get started though, remember to make sure you're following the safety rules of the shop. Wear your safety glasses at all times. Always roll up your sleeves. Tie back your hair. Make sure your shoulders, midriff, and back are covered. Closed-toed shoes. Pants or shorts that cover your knees. No dangling objects. And check the people around you. When machining, the stock must be secured either by clamping in a vise or by clamping it directly to the milling machine table. Most commonly, you will use a vise like this to hold your stock in place. These are parallels, and they are used to raise the stock above the sides of the vise so that the end mill can cut the material without cutting into the vise. Parallels are precision tools and should only be used in a vise, on the mill, or on the drill press. Before putting stock into the vise, always clean off the vise and parallels using a rag to remove any metal chips. Chips can affect your part's dimensions since they keep your stock from sitting perfectly flat in the vise. When securing your stock, make sure that it is held firmly. Clamp the end of the stock to be milled close to the vise. You want to leave enough room to mill the material to the desired dimension, while also minimizing vibration at the end of the stock. This is why stock for milling is cut just a 1/4 inch longer than the specified dimension. Next, I will demonstrate the 4 main tools used in conjunction with the milling machine: the end mill, the edge finder, drill chuck, and tap guide. I'll also remind you about the deburring tool. The end mill is the milling machine's main cutting tool. The end mill cuts along the sides of the part. It's not good for drilling, since the cutting edges are on the side of the tool, not the bottom. There are 2 ways to cut with an end mill: conventional and climb. In conventional milling, the part is pushed into the rotation of the end mill blades. In climb milling, the part is moving with the rotation of the end mill blade, creating a smoother finish. For safety reasons, conventional milling is the preferred method at GRT. Climb milling pulls the part into the cutter and should only be used for a finishing pass. This is a 1/2 inch edge finder. An edge finder is used to set the DRO 0 at the edge of your part, so you can make accurate measurements. The same edge finder can be used to set either the X0 or the Y0. The 1/2 inch edge finder goes directly into the 1/2 inch collet. Drill chucks are used to hold drill bits of 1/2 inch or smaller diameter. If you want to use a drill bit larger than 1/2 inch diameter, use a silver and Deming drill held directly in the 1/2 inch collet. Each of our large drill bits have a 1/2 inch diameter at the top. We have 2 types of drill chucks for the milling machine: one that goes into the 1/2 inch collet, and one that goes directly into the spindle. They both have adjustable jaws at the bottom, so you can insert any drill bit smaller than 1/2 inch. When inserting your drill bit, make sure the jaws of the drill chuck clamp evenly onto the drill bit so the drill bit is completely straight. This is a center drill. The center drill is used with a drill chuck to mark the location of a hole. The divot created by a center drill also prevents the drill bit from walking or moving away from the specified hole location, which could potentially lead to both inaccurate drilling and stress on the drill bit. Once you're finished working on your part, your part will have very sharp edges, called burrs. It's easy to cut yourself on the sharp edges, so to make sure your part is safe to handle, you must deburr it using a file. And/or a deburring tool, as described in Hand Tools video number 2. Parts must be deburred before they are turned in for QC or quality control. There are 4 operations you can do on the mill: facing, drilling, tapping, and slotting. Before working on your part, it's best to zero the DRO to the edges of your part using an edge finder, which will allow you to make precise measurements and cuts. Here are the steps for finding the edge of your part. Number 1. Set the machine speed to approximately 1000 RPM. Number 2. Insert the edge finder and call it. Number 3. Uncenter the bottom of the edge finder by gently tapping the lower side. Number 4. Turn on the milling machine. Number 5. Slowly bring the edge finder to the edge of the part until the edge finder becomes centered. This will be apparent when it stops wobbling. Number 6. Keep moving the edge finder slowly in the same direction until it just becomes uncentered again. Number 7. Stop and zero the DRO axis that you were moving. Lastly, repeat steps 3 through 7 until the DRO reads less than 0.003 of an inch difference between attempts. Right now, the DRO 0 is set to the edge of the tool. If you will be drilling, then you should zero the DRO onto the axis of rotation of the spindle, rather than the edge of the tool. For the x-axis, after zeroing the x-axis, continue moving the table in the same direction until the DRO reads minus 0.25 inches if the tool is on the right side of the part, or positive 0.25 inches if the tool is on the left side of the part. Then press the 0 button again. For the y-axis, after zeroing the y-axis, continue moving the table in the same direction until the DRO reads minus 0.25 inches if the tool is on the side of the part farthest from you, or positive 0.25 inches if the tool is on the side of the part closest to you. Then press the 0 button again. The facing operation cuts along one side of your stock. When facing, you should only take off 0.050 of an inch for roughing passes and 10 to 20 thousandths of an inch for finishing passes. For example, let's say I want to make the length of this box beam 100 thousandths of an inch shorter. Here are the steps to face my part. First, find the right side edge of the stock and zero the x-axis. I'm edge finding the right side of the stock because cutting on the right side of the stock allows me to make a conventional cut, assuming the cutter is spinning in the clockwise or forward direction. Number 2. Remove the edge finder and insert the 1/2 inch end mill into the collet. Number 3. Lower the quill to position the end mill so that it will cut the entire side of the part. Then lock the quill. Number 4. Turn the x-axis handwheel until the DRO reads 50 thousandths of an inch, which is the amount I want to cut for a roughing pass. Lock the axis that you won't be moving. In this case, I'm cutting along the y-axis, so I will lock the X-axis to prevent it from wandering and giving me a non-straight cut. Number 5. Turn the power switch to the forward position and add a thin coat of oil to both tool and the part. Number 6. Turn the Y-axis hand wheel counterclockwise slowly and consistently to move the part completely across the spinning tool. Number 7. Turn the Y-axis wheel clockwise to return the tool to the starting position. Number 8. Repeat steps 4 through 7, but have the DRO set to 70 thousandths of an inch, then 90 thousandths of an inch, and finally 100 thousandths of an inch, which means you're cutting a smaller amount of material as you get closer to your specified dimension. The drilling operation makes holes in a part, and the milling machines are the best choice for precisely locating drilled holes on a part. The rotational speed used for drilling depends on the diameter of the drill bit. Refer to the chart on the top of each mill to determine what speed you should use for your drill bit. In general, the larger the drill bit diameter, the slower the speed. First, find the edges of your stock and zero the X-axis and Y-axis. Then, once you've finished edge finding, offset the DRO zeros by 0.25 inch to set the DRO zeros on the drill bit's axis of rotation. Number 2. We'll start by using a center drill to mark the location of the hole. Insert the drill chuck into the spindle using the pneumatic power drawbar. As you tighten the drill chuck, be sure to wiggle the center drill so that the jaws evenly clamp onto the center drill. Number 3. Turn the X and Y hand wheels to move the table to the specified hole location. Then, remember to lock both table axes. 5. For Rocky, turn the machine on and rotate the speed change hand wheel until you reach the appropriate speed. Changing the speed on Bullwinkle will be explained later in this video. Number 6. Push the center drill into the part by rotating the quill feed knob counterclockwise very gently. 7. Bring the quill up and turn the machine off. Take out your center drill and insert your drill bit. Try not to move the table during the step, since you will lose the exact position of the divot you made, and you may not be able to move the table back to its exact location. Number 8. Turn on the machine and put a tiny bit of oil on the divot and on your drill bit. Number 9. Slowly bring the drill bit towards and into the part. While drilling, you should peck, which removes the material from the flutes of the drill bit by breaking the chip before it gets too long. If you hear a high-pitched noise while drilling, this either means your machine speed is too fast, you're not pushing down hard enough, or you have a dull bit. Number 10. When the drill bit is completely through the part, bring the tool up and turn off the machine. Number 11. Take the part out of your vise and deburr the holes. Tapping is the operation that cuts threads in a hole so that a screw or bolt can be fastened. The drawing sheet will specify the specific thread to cut, and you will need to drill the appropriate hole as indicated by the chart before the tapping operation. After drilling the hole, don't move the table. You'll need 3 things: the tap guide, tap handle, and the tap. Here are the steps for tapping a hole. Number 1. Insert the tap guide into the collet. Number 2. Put the tap into the handle. Number 3. Position the tap handle between the drilled hole and the tap guide. Remember that you should also add a little bit of oil before turning the tap handle. Lastly, turn the tap handle clockwise half turn, then counterclockwise quarter turn, continuing until the tap is completely through the hole. The slotting operation cuts a slot in the middle of a part, like this. For this, we will need a drill bit and an end mill. Number 1. First, lock the table and drill a slightly undersized hole using a drill bit and a drill chuck. The drill bit should be slightly undersized to make sure you don't drill a hole bigger than the end mill. Number 2. Without unlocking or moving the table, insert the end mill into the collet. Number 3. Turn on the motor, then plunge the end mill into the hole. Number 4. Unlock the axis you want to move and rotate the appropriate hand wheel to cut the slot into the material. Number 5. Without moving the table, bring the spindle up and out of your part. Number 6. Remember to deburr the slot. Each mill has adjustable speed, which means you can change how many revolutions the spindle spins in a minute. Depending on how much material you plan on taking off, you'll have to adjust the speed accordingly. When facing with a half-inch end mill, set the speed to approximately 1200 RPM. If the RPM is set incorrectly, it could cause loud squeaking and rougher cuts. For drilling, each mill has a sheet attached showing which speeds should be used depending on the size of your drill bit. For edge finding, change the speed to 1000 RPM or as close as you can get. Bullwinkle has a different system. Right now, Bullwinkle is set to its highest RPM. First, you'll have to unplug the machine by twisting the plug counterclockwise. Then, open up the 2 covers on the side of the mill head. Inside, you'll find a single belt, which links the motor to the collet. Look at the chart on the front of the machine to figure out where to move the belt. Loosen the motor and move the belt to change the collet speed. Moving the belt downwards increases the RPM, while moving the belt upwards decreases the RPM. Make sure the belt is fully secured by pulling on the belt to rotate a collet a few times. Once that's done, remember to lock the motor back into place, replace the 2 covers on the side, then plug the milling machine back in. Once you finish machining your part, remove and wipe all the tools, including your vise and parallels, then put them away. Then clean up your work area by sweeping away long strands or large chips of metal before using the wall vacuum to suck up remaining metal chips on the table surface and in the T-slots. Use the push broom to sweep the floor and use the vacuum or dustpan to clean those chips up. And that does it for our second installment of our GRT Mill training series. I hope this video has given you all a better understanding of how to correctly and safely operate the milling machine. If you have any questions, feel free to ask them during class so everybody can learn the answers. Stay safe, everyone, and I hope to see you all working in the shop soon.